Welcome, ladies and gentlemen. So what I like to do is show you how to factor higher order polynomials using special products. And the special product we're going to do for this one is a perfect square trinomial. Now, again, a couple examples of perfect square trinomials. Let's just kind of go with an easy one, x squared plus 2x plus 1. And again, this is perfect square trinomial because basically what we have is our first term is squared, our last term is squared, and our middle term is 2 times the product of our first and our last term, a times b. Okay? So that's kind of like our formal definition of a perfect square trinomial. And that's kind of going to be kind of the pattern that we're going to be looking for to make sure we can verify that we have a perfect square trinomial before we can factor it. But what's nice about this is we know that the factored form is going to be a plus b times a plus b or a plus b squared. And again, that could be plus or minus, and then that would be plus or minus as well. So if that's minus 2ab, then those two would be minus as well. So again, you look at this and you say, all right, is this a squared term, x squared? Yes. Is 1 a squared number? Yes. Is 2 times x times 1 the middle term? Yes. So therefore, I could just write this as x plus 1 squared, factored. Or you could say, what two numbers multiply to give you 1, add to give you 2? Oh, that's x plus 1 times x plus 1. Okay? So we're going to be looking for this, but we're not going to be dealing with quadratics or terms raised to the second power. We're dealing with higher order polynomials. So what usually gets students a lot of times when we're dealing with higher order polynomials is the powers that our polynomials are raised to. So the best thing I like to let students kind of do is let's just replace. Let's have x to the fourth equal x squared. And if x to the fourth is equal to x squared, then we're going to have x squared then equal to x. So if I go ahead and do that, then I can rewrite this as x squared plus 8x plus 16. This is in a format that's much more familiar to me, you know, as a student would be looking at this, that I can identify, I can factor that. I'm a little bit more comfortable. I don't even need to know special products. I feel more comfortable factoring this. What two numbers multiply to give you 16, add to give you 8? I know those two values are 4 and 4, right? But again, we could also look at this. X squared is a square term. 16 is a square term. 2 times x times 4, because you could say that that's x squared plus 8x plus 4 squared. So 2 times x times 4 equals 8, and that's true. So that's a perfect square trinomial. Now we also might know that the answer here is going to be x plus 4 times x plus 4, which is x plus 4 squared. Now, kind of using that as an understanding, let's go back to our problem. X to the fourth plus 8x squared plus 16. Is x to the fourth a squared term? Yes, it is. X squared squared. And is 16 a squared term? Well, yes, of course. That's 4 squared, right? And then if you were to multiply 2x squared times 4, that gives you 8x squared. So that's your middle term, so that's correct. So therefore, again, remember to write a perfect square trinomial. As long as you know the first term is a square term, the last term is a square term, and the middle term is double the first and the last term, not them squared, but just them as a and b. Therefore, then all you need to do is write the first term, x squared plus 4 squared. And that's it. And if you were to multiply that out, you just check your answer, which we can do. X squared plus 4 times x squared plus 4. X squared times x squared is x to the fourth, which we need. X squared plus 4x squared plus 4x squared plus 16. X squared plus 8x squared plus 16. Perfect. Okay? So again, if you're having trouble, rewrite them down as squares. And just think of them as squared so you can go ahead and factor this. Again, if I was having trouble with this one, I might want to rewrite this as 16x squared minus 24x plus 9. And then I could say, can I rewrite this as a square term? Sure. That's 4x squared minus 24x plus 3 squared. Okay, is my middle term 4x times 3 times 2? Yes, it is. So therefore, this would be 4x plus 3 squared. However, what you can probably notice here is we're not dealing with x. We're not dealing with something raised to the second power. We're dealing with it to the fourth power. So therefore, what I would do is to change this is I would just make that as squared. Because what's 4x squared squared? Well, that's still going to give you 16x squared, or 16x to the fourth is what we need. So the only thing to change this to correct my problem would just make that 4x squared. Again, you can multiply that out. That's going to give you x to the 4th. Now, when we start getting into powers that are like to the 5th power, what we realize is, well, we can't use you can't have values that are exactly the same that are going to multiply to the 5th. So what we want to first do is see if we can multiply out a common factor. And you can see in this case, each one of these terms has an x. So if I factor out an x, I'm left with x to the 4th plus 2x squared plus 1. Based on my first example I did, I know this is a perfect square trinomial, but again, it's raised to the 4th power. So my first two terms of my factors is not going to be x times x, because x times x gives me x squared. I need this to be x squared times x squared. And then to give me my last term 1, I need to be plus 1 and plus 1. So I can rewrite this as x times x squared plus 1 squared. Okay? All right, so let's go and get in here. So now, I thought I had some subtract. Oh, I did do. Oh, shoot. That's minus. My bad. That's a minus. Minus. Big one. Big mistake. Did I do 2 minus? 1, 2. I guess I only did 2 minus. OK. Yeah, sorry about that. The middle term is negative. So it's 2 times 3 times. But you got to multiply to give you negative. So you got to make sure that's negative. Big mistake. I overlooked that. Over here, I have x to the 4th. Again, we want to say, can I rewrite the first term as a square term and the last term as a square term? Well, yes. That's going to be 5x squared plus 1 squared. Is my middle term this times 2? Yes, it is. So therefore, all I need to do is write the first term and the last term. Since my middle term is negative, that means my product is going to be negative as well. And that's why special products can be so helpful rather than trying to factor everything and so forth. Over here, I have to the 6th power. And again, I could look at this as factoring as, x to the 3rd. Like if you had x to the 3rd times x to the 3rd, that would give you x to the 6th when you add them. But the problem is my middle term is not to x to the 3rd. So therefore, that's not going to work. So again, what I'll need to do is look into factoring. So in this case, I can factor out a x. I guess that was not supposed to be that way. I think this was supposed to be an x squared. Yeah, it was supposed to be an x squared. So therefore, if I factor out an x squared, I'm left with a 4x squared plus 12. I'm sorry, that's x to the 4th, plus 12x squared minus 9. Okay, now again, we want to check. Can our first term be written as a square term? Yes, that's 2x squared plus 12x squared minus, can 9 be written as a squared number, a number squared? Yes, 3 squared. Is my middle term 3 times 2x squared times 2? Well, that's 6x squared, that's 12x, perfect. So therefore, I just take my first term and my last term, 2x squared, my middle term is positive, so that's plus 3 squared. Okay, and last but not least here, again, I can factor out a x cubed. And when I factor out an x cubed, I'm left with a x squared plus 6x plus 9, which is, again, you can factor this. Again, this one's to a squared, so that even makes it even better. But again, what two numbers multiply to give you x? X squared. What two numbers multiply that are exactly the same that multiply to give you 9? That's 3. So the exact same thing I'm doing here. What two numbers that are exactly the same give you 4x to the 4th? Well, that's 2x squared. What two so you just kind of come back through again, and you get x plus 3 times x plus 3. Or we write it as x plus 3 squared. So there you go, ladies and gentlemen. That is how you multiply higher order polynomials using perfect square trinomials. Thanks.